Quantum sent us this link here. Yes, go to the site. All right. A small number of samples can poison LLMs of any size. Oh. In a joint study with the UK AI Security Institute and the Alan Turing Institute. I didn't know that was still around. The Alan Turing Institute. What do you know? We found that as few as 250 malicious documents can produce a backdoor vulnerability in any large language model. How do you know? Interesting. Only 250 malicious documents. I mean, that's still a lot. But granted, in the large scale of things, when you're talking about the number of documents to train these large language models, it is like a tiny amount. But 250 still is a lot. So a 13 billion parameter model is trained on over 20 times more training data than a 600 million model. Thank you for the likes, you guys. Both can be backdoored by the same small number of poisoned documents. Oh, yeah. I mean, it makes sense because, I mean, it doesn't matter if it's 13 billion or 600 million, right? You're still updating the model with training deltas, right? Training deltas. There you go. Training delta results challenge the common assumption that the attackers need to control a percentage of training data. Instead, they must just need a small fixed amount. This is dangerous. This is a danger zone, right? This is actually really... Study focuses on a narrow backdoor producing gibberish text that is unlikely to pose significant risks in frontier models. Nevertheless, we are sharing these findings to show that data poisoning attacks might be more practical than believed previously, and to encourage further research on data poisoning and potential defenses against it. There we go. I'm not kidding. I just read that on LinkedIn. It's danger zone. We're in a danger zone here. Here's the good news. By discovering this defect, or essentially this vulnerability in the model, we can protect against it by cleaning the data ahead of time, right? You want to clean the data, or at least prepare the data just in case, and be ready. And good news is, now that we have these large language models, we can use them to classify the documents that we're training for future models that we're building. And that's why they keep getting better, because of the synthetic data labeling and annotation. Can you brief the vulnerability? The vulnerability is basically if there are a small number of documents that can it creates a backdoor, which means that if the data in those documents can trigger the parameters down a code path, or at least a parameter path, to override maybe some of the model's like safety precautions, or override what the outputs are going to be by just a few keywords that are triggered. You can add a few keywords that override the model's other learnings, and then you can take control of the model that way. I think that's what this is saying. I'm pretty sure I think that's what this is saying, which is kind of neat. It's kind of neat, but also be very careful. I remember that meme that the threatened to poison all humans created data for AI to be slop. That's right. You can do that. You can create, if you embed some extra like malicious statements in your code to like poison the model, you could totally do that. XSS, cross-site scripting. There are a lot of vulnerabilities with cross-site scripting. The good news today is the web browsers, they come with extra built-in security design patterns that, for the most part, de-risk some of XSS. So there you go. It de-risks some of it. One example of such an attack is introduced as backdoors. Backdoors are specific phrases. Right here. That's what I was just talking about. Phrases that trigger a specific behavior from the model that would be hidden otherwise. Hey, we're on the right track, aren't we? If, for example, LLMs can be poisoned to exfiltrate sensitive data when an attacker includes an arbitrary phrase like pseudo, like a pseudo phrase, like the pseudo make me a sandwich. In the prompt, all you got to do is include your little phrase. These vulnerabilities pose significant risk to AI security and limit the technology's potential for widespread adoption in sensitive applications. Would this attack give the attacker some kind of bind shell into the system where the system commands can be executed? Sort of. I mean, if we're talking about the attack here, the vulnerability that's described here in this Anthropic article, it's not necessarily, it depends on how you deploy it. So you could have AI model that does have access to crucial or critical systems and privileges. If you had implemented this strategy where you train the model on some malicious documents with the backdoor, you could override the model and gain shell access. On poisoning models, assumed adversaries controlled a percentage of the training data. This is unrealistic because training data scales with the model size. Using the metric of a percentage of the data means that the experiments will include volumes of poison content that would be likely never to exist in reality. But we've got a new study now. Guess what? This new study, a collaboration between Anthropic Alignment Science Team and the UKAISI Safeguard Team and the Alan Turing Institute, the largest poisoning investigation to date, it reveals that a surprising finding in their experimental setup with a simple backdoor designed to trigger low-stakes behaviors. Thank you for the likes, you guys. Poisoning attack requires near constant number of documents regardless of the model size or the training data size. So you don't need, it doesn't matter. You can, as long as you control, thank you for the likes, you guys, as long as you control just a set size of backdoor documents, you can, that most AIs are trained on, and you could like backdoor the model. You could open it up and make it do things it's not supposed to do, or that it's been trained not to do. This finding challenges the assumption, thank you for the likes, existing assumptions that no longer models require proportionally more poison data.